Welcome friends. So I have taken today a problem of three-dimensional geometry from the previous year question of West Bengal Joint Entrance Examination 2016. So without wasting any time, let's start the solution. So to find the cosine of the angle between any two diagonals of a cube is this. So we have to find the correct option. So consider this structure as a unit cube. We know that it is not a cube, but consider this for this purpose. So if we consider this as a cube, we are considering here the inner diagonals. So how many inner diagonals this cube has? Only 4 inner diagonals this cube may have. So if we consider any two pair of inner diagonals, then first we are going to find the direction ratios of the diagonal lines. Then if these are the two diagonals of a cube, then if its direction cosines or direction ratios are given of these respective lines, then it is very easy to find the cosine of the angle between these two diagonals. So first draw the diagram. Next page. So suppose this is a unit cube. Consider this point as the origin of this cube, named as O, and this one take as x-axis. This one, if we extend this side, take this as y-axis, and if we consider this vertically, consider this as z-axis. So this is X, Y and OZ. Now we name the vertices of the cube O, A, B, C, D, E, F, G. Now as this is a unit cube and we have considered this point O as origin, so it is very easy to determine the coordinates of these points or the vertices of the cube. What are the coordinates? If we consider the point A, we have to, if we start walking from this origin O towards A, so it is 1 unit towards x-axis, 0 unit towards y-axis and 0 unit towards z-axis. So 1, 0, 0 is the coordinate of the point A. Similarly, if we start walking from this point O towards the point B, so 1 unit from x-axis, 1 unit towards y-axis and 0 unit from towards z-axis. So B, coordinate of B has been derived. What is the coordinate of C? C is nothing but 0, 1, 0, because towards x-axis 0 unit, towards y 1, towards 0, towards z 0. Okay, so now coordinate of D: 0, 0, z-axis 1. Okay, so now E, coordinate of E: x 1, y, x-axis 1, y 0, z 1. Coordinate of G: x towards x-axis 0 unit, towards y-axis 1 unit, towards z-axis 1 unit. F, point F. If we start walking from the origin O to reach the point F, we have to walk 1 unit towards x-axis, 1 unit towards y-axis and 1 unit towards z-axis. So we have derived all the coordinates of the vertices with respect to the coordinate axis X, Y and OZ. So now what are the inner diagonals? Here we are considering only inner diagonals. The inner diagonals of the cube are, if we consider this point D, so DB and OF, this is one pair, and another pair is GA, G point from this point G to this point A, and from this point C to the point E. So this is another pair. So to determine the angle between the diagonals, we will consider either of this pair, either one of this pair. So let us consider angle between diagonals, previous page, DB and OF be alpha. Now we know that if a straight line is given and it is passing through two given points, it is very easy to find the direction ratios of this straight line. So if you want to find the theory, if you want to know the theory of this concept, then you should check out my playlist on my channel, maybe lecture 3 or 4, lecture number 3 or 4 in the geometry, 3D geometry capsules. Okay, so the direction ratio of the diagonal line DB equal to, here the point D whose coordinate is this is the coordinate diagonal D, and we will use another ink, not blue one. Okay, so if we join this diagonal DB, so the direction ratio of this straight line passing through this point 0, 0, 1 and 1, 1, 0 is 1 minus 0, 1 minus 0, 0 minus 1. So here I have applied the concept of a direction ratio, how to find the direction ratio of a straight line passing through two given points whose coordinates are given. So here it is simply equal to 1, 1, minus 1. Similarly, hope you have understood this. If you still have any doubt, please go through the NCERT book or 3-dimensional geometry class 12 part 2 book, or otherwise you can go through the lectures of my playlist section 3D geometry capsules, okay, of my channel. Okay, similarly the direction ratios of diagonal line another line is OF are, previous page, point O whose position coordinate is 0, 0, 0 and this is F. If we join this, undo, if we join this is the diagonal, so DB and OF. So OF, so 1 minus 0, 1 minus 0, 1 minus 0, so 1 minus 0, 1 minus 0, 1 minus 0, so this is 1, 1, 1. So we have in our hand, name this as A1, B1, C1, and this was as A2, B2, C2, same. Okay, so now we know that if two lines, straight lines, exist in the three-dimensional space and its direction ratios are given or direction cosines are given, here in this case direction ratios are given, then if alpha be the angle between these two straight lines, then cos alpha equal to, what is the formula? Therefore the angle cos alpha equal to a1 a2 plus b1 b2 plus c1 c2 by root over a1 square plus b1 square plus c1 square root over a2 square plus b2 square plus c2 square whole magnitude. So here this theory also I have discussed in the lecture series of three-dimensional geometry. You just go through my previous lectures, you can find the angle between two straight lines. So here a1 b1 c1 a2 b2 c2. So 1 into 1, 1 into 1 and 1 into minus 1. So in the numerator 1 into 1 plus 1 into 1 plus 1 into minus 1 magnitude by root, previous page, 1 square plus 1 square plus minus 1 square, 1 square plus 1 square plus minus 1 whole square, root, okay, another is 1 1 1, so 1 square plus 1 square plus 1 square, so whole magnitude, so equal to 1 plus 1, here minus 1, so here in the numerator we have 1 in our hand. So here 1 plus 1 plus 1 3, root 3, here also root 3, so 1 by 3. So cos alpha equal to 1 by 3. So we have reached to the end of this problem. So we will check out the options. So this is the right answer. Option A is the correct option, 1 by 3. So hope you have understood this beautiful problem. And another problem I have arranged for you. Take this problem as the home assignment. So if you are a serious student, then please solve this problem and comment the answer in the comment section below. So I hope to see you in my next video. Thank you for watching.